Welcome back to another video on geometry. Today we're talking about more examples for questions on quadrilaterals. So in total we actually have 4 examples to cover, but the quadrilateral series is very extensive and a lot of things will come out. So what you want actually to grasp is the key concepts. So let's talk about our first example, continuing from the previous video. So in the figure below, ABCD is a trapezium. AD is parallel to BC and BC equals to EC. Angle BEC equals to 72 degrees and angle ADC equals to 65 degrees. Find angle ECD. So first, for geometry questions, it's very important to identify information that is important to us. Then we need to label it out on the figure. If not, we may miss it out accidentally. So AD is parallel to BC, so we do that. And with that, we can actually find our first major angle that will help us solve the problem. So in the previous video, I emphasized how actually interior angles, parallel lines keep coming out, right? Well, in here they came out again. So with our AD being parallel to BC, we can find angle BCD, which is 180 degrees minus 65 degrees equals to 115 degrees. Cause of interior angle parallel lines. And next, BC equals to EC. We see something very special. Actually, this CEB is a triangle. And from triangles, we can recall this. If you want to find our ECB, because our ECD is BCD minus ECB, I know a bit confusing, but you all can look at the figure. We need to find our ECB, angle ECB. And how do we find that? Angle sum of triangle. Because we know that since BC equals to EC, angle CEB equals to angle CBE. So it's an angle sum of isosceles triangle to be specific. So our angle ECB is basically just 180 degrees minus 2 times 72 degrees. Why 2? Because CEB is equals to CBE. And with that, we can actually find angle ECD, which is 115 degrees minus 36 degrees equals to 79 degrees. And with that, we have actually solved the question. Yeah, well, it's actually quite a mouthful of angles to say, but yep. Basically, angles is basically like one big minus one small, which will give you our angle that we require most of the time. And now, this is actually a very interesting question that I came across, which is not very common, but it's interesting. And it's actually involving drawing of a trapezium. So before we start, let's recall what a trapezium has. Basically one pair of parallel lines, right? That's the information that the question didn't give us. But this question specifically gives us a special information. There are 2 right angles in ABCD. Wow, 2 right angles. So how do we solve this question? First, we need to identify what we know. So first, like I mentioned, trapezium got 1 pair of parallel lines, and for this there are 2 right angles. So if you use the trick from the first lesson in this chapter, we will realize that AB is not perpendicular to BC. So there are 2 perpendicular lines to be drawn, and one of these lines need to be parallel to either AB or BC. So you can see the link here. And okay, let's ignore what the question show. BC is parallel. They are not fun. So we look into the various possibilities. So possibility 1, our DA, which is the point that's not drawn, is perpendicular to AB. So how do we draw a perpendicular line? Let's recap. We identify the line. Outline it is a 4/2, and then we flip it to connect it. I know it's a bit not connected, but basically is something like that. And then, okay, to make a four-sided figure, you only got one choice. You should connect D to C. So we connect it, and it looks quite sus. Where's my right angle, and where's my parallel lines? So this is a wrong possibility. So next possibility, BC is perpendicular to CD. So okay, using BC, we draw a perpendicular line, or make a perpendicular line, and we get our right angle. And how do we connect again? Like as I said, there's no choice. If you want to make a four-sided figure, you can only move it to connect it to A, and connect it. And then okay, there's two more things you need to check: right angle, one right angle, and pair of parallel lines. So we check our right angle first. So I realize, actually this CD, you outline it and you flip it 90 degrees from vertical to horizontal, we will get this thing, which is a clear indication that this is our correct answer for right angle. Then we check our parallel lines. So right now, right, we're looking at our figure, BA and CD can't be parallel. So it has to be BC and AD. So we check. BC like that, AD like that, and like that. And as I said, the ratio of the vertical grids to the horizontal grids must be the same. So for this is 3 to 1. For this is 6 is to 2, which is 3 to 1. 3 is to 1. And that shows that it's parallel. And with that, we get our answer actually. So, in summary, when doing these type of questions, right, what you need to do is mark out parallel and perpendicular lines as well as equal sides, like what I mentioned. Get information, write it down. So, for each quadrilateral, recall the associated properties of that specific quadrilateral. Trapezium, one pair of parallel lines. Parallelogram, two pair of parallel lines, opposite sides are equal. And then from there, they also work hand in hand with angle properties like interior angles, parallel lines, adjacent angles on a straight line, angle sum of triangle. And then find angles needed to solve the answer, or you apply drawing rules like what I covered in example 4. And with these 4 tips, it should be quite natural as you practice more, because like I mentioned in the previous video again, quadrilateral questions come out in many different ways. Even sometimes we not expect it, but through doing more of it, we actually train our thinking process, and when we see the question, we know what angles to find.